Math with Oscar class. That's my dad.
When we move from talking about the volume of a prism to the volume of a pyramid, there's a fundamental relationship we need to have in our basket of tricks. Primarily, it has to do with how this original prism is related to the pyramid hidden inside it. So, if I were to place a dot there at the center of the top of this and bring down my lines, you can see that pyramid locked inside my prism. What's important to note is that the volume of that pyramid now is equal to 1/3 of the volume of the original prism. So the volume of my pyramid is 1/3 whatever prism was inside it. This applies both to rectangular prisms as well as cylindrical prisms. For example, if I were to take a cylinder so there's a cylinder, and I were to shave off the excess, leaving me something that comes to a point, you can see that what's left is a cone. The same rule applies. The volume of that resulting cone is 1/3 the original volume of the cylindrical prism that made it. Meaning, the formula for the volume of a prism, of a pyramid, or the formula for the volume of a cone is no different than the prisms. The shift, the change, is we simply add the 1/3 on to make up for the fact that it's not the full object. Using this, we can then go forward to get the volume of these various objects. Let's take a look at a couple examples now. In this example, I have a rectangular pyramid. It has a base with sides 11 and 18 and a height or altitude of 23 meters. Now, comparing this to our problems with surface area, you'll notice that I'm not talking about the slant or the distance up the side of the pyramid. I'm referencing this drop-down point smack dab in the middle. Be very careful with the information you're given. Many problems will present to you a pyramid and ask you to calculate the surface area and the volume. Be sure that you have the values you need to proceed before you do so. Now, from what's given here, I can go ahead and start applying the rules I know. The volume, for example, we know is 1/3 that of an equivalent prism. So 1/3, now I approach this as I would a prism. The area of the base times the height. So 1/3, the base in this case is a rectangle, so that's 11 by 18. And now I can look at the altitude or the height of my prism. In this case, it's 23. 23 units up there. Again, think of this as having been stacked and then shaved off. I've cut off pieces. Or perhaps you could think of it as a stack of ever shrinking rectangles. So again, start with your original base and multiply that by the height of that shrinking stack that eventually comes down to just a little point there at the top. Now, calculator time. Let's see what we've got for our final answer. I take 11 times 18. That's my base. I'm going to multiply that by 23. That's my altitude. And I'll divide that whole thing by 3 or multiply by 1/3. That gives me a volume of 1,518 cubic meters. 1/3 area of the base times the height, and then you can substitute through. This doesn't change for cones. Let's take a look at one of those. Here I have a cone with a radius of 16 centimeters and a height of 34. I'm going to apply the same principles we've applied so far with finding its volume by first thinking of it as a cylinder, which I will then cut back to 1/3 of its original volume. So in this case, the volume is going to be 1/3 the area of the base times the altitude or the height. So in this case, what I'm going to do is, let's plug everybody in. I have a circular base. So that's going to be pi times r squared times a height of 34. And you can see pi r squared provides me the area of that circular base. The height provides me the volume of a cylinder. 1/3 cuts out the extra, leaving me just my cone. And the other nice thing with volume and cones is that it's no different than pyramids. There's no weird formula to remember like there was in surface area. So you recall from surface area, we had to deal with that wraparound piece. We don't have that component here. So, stop. Calculator time. Let's see. 16 squared times 34. I'm going to double check that math. 16 times 16 times 34. Yes, that's a big number. Divided by 3. Well, now I've already introduced decimals into my work, because this works out to be 2901.33 pi. And at that point, now perhaps it might be easier not to leave it in terms of pi, since this is no longer an exact answer. You will see, on occasion, they won't write this out. They'll actually write it as a fraction involving 3, multiplying it by pi as your final answer. Let me write that answer down as well. So for example, you may see this, 8704 over 3 times pi. That's the same thing. If I were to do 8704 divided by 3, I get this decimal down here. And part of that is playing to the idea that when we talk about exact answers, it's okay to leave them in fractional form. To avoid confusion, let's just turn this into a straight up decimal and wrap it up. So I'll take this divided by 3, multiply that by 3.14 as our approximation of pi, and I have a final answer of 9,110, in this case, cubic centimeters. All 3 of these would be acceptable answers to this problem. And again, when we're dealing with cones or pyramids, it's really just the exact same thing we did with prisms, except it's 1/3 the volume. Good luck.